Okay, here's an answer key for slide 13 from the lesson. We're going to write an equation that matches the polynomial. So a couple things we want to look at before we start is what degree is this polynomial? And if we follow the graph, we see it goes up, down, and up again, 3 different directions, so third degree, or you could use the idea of 2 turns, and the number of turns is 1 less than the degree. So we should end up with a third degree equation. And then we follow the steps here. So if we look first at the x-intercepts, we have an x-intercept at -3, another one here at 0, and an x-intercept here at 2. And if we want to write those as factors, we're going to set them equal to 0. So we'd have x plus 3. X plus 0 is still just x, and x minus 2. Okay, we want to find a point on the function. So you could pick this point up here or this point down here. I'm going to pick this one, which looks like it is over 1 down 4. So it's the point 1, -4. And then I'm going to plug that point into the equation. Now remember, we're trying to find an a value. So the a value is a coefficient that we're going to multiply the equation by. So I'm going to plug in -4 for y. So I have -4 equals a times, and then I'm going to plug in 1 for x. So we have 1 plus 3 times 1 times 1 minus 2. So 1 plus 3 is 4 times 1. 1 minus 2 is -1. We're going to multiply all these together. 4 times 1 times -1 is -4. So we have -4 equals a times -4. If we want to solve for a, we're going to divide by -4. -4 divided by 4 is 1. So it's always good to check and see if there is an a value. In this case, the a value is 1, so it doesn't change the equation. So our final equation is y equals, you could write the 1 in there, you don't need to, x plus 3 times x minus 2. And oftentimes you'll see this plain x here at the front of the equation. So you could write it as y equals x times x plus 3 times x minus 2.